Hello and welcome to my channel. In this video we are going to solve an example from geometry. The figure above shows two semicircles that are tangent to each other at point B. And ray DE is a tangent to both the semicircles at points E and F. If the length of PB is equal to the length of BC is equal to 6 units, what is the length of the line segment ED? So here we can clearly see that there are two semicircles given and they touch each other at only a single point B. Now the ray DEF is acting as a tangent to the semicircle which touches the small semicircle at only one point E and touches the big semicircle at point F. Now the next thing they have given is the length of PB. Now P is the center of the big semicircle. So PB is going to be the radius. So the length of the radius is given as 6 units. Similarly, the length of BC is given as 6 units. For the small semicircle, the line BMC acts as a diameter since M is the center of the circle and BC is a line passing through the center. So the length of the diameter is given as 6. So if the diameter is 6, we can take BM as the radius. So it will be half of the diameter. So we can write here 3. Similarly, MC is also 3. Next, let us concentrate on these 2 points, F and E. If we connect the center of the circle to this point F, then PF becomes also the radius of the given semicircle. Since here PB is given as 6, PF also becomes 6. Similarly, we can connect the point M, that is center of the circle, to point E over here. And ME also becomes the radius. And the radius of the small semicircle is 3 as we see here. So ME also becomes 3 units. Now once we have got these values, we can clearly see that there are two triangles in this given figure. One is the triangle PDF, the big triangle, and another one is the triangle MDE, that is the small triangle. Now remember that we have to find the length of this segment ED. So let us keep it as X. Now I am going to draw the two triangles separately and check whether these two triangles are similar to each other or not. So let me draw these two triangles again. Now, in these two triangles, we can see that angle D is acting as a common angle. That is, angle PDF is equal to angle MDE. It's a common angle. So we can just mark over here, angle D is equal to angle D from these two triangles. Now let us check at the angle F and angle E over here. Now we know that DEF is acting as a tangent to the given two semicircles and PF and ME are the radius. So using the radius tangent theorem, we know that the radius always makes a 90-degree angle with the tangent. So angle PFD becomes 90 degree. Similarly, since ME is the radius, it also makes 90 degree with the tangent. So these two angles are also same. So let us mark over here. Angle F becomes equal to angle E. Since two angles are same, the third angle also becomes same by using angle sum property of a triangle. Since the angles are same, we can say that by using angle-angle similarity criteria, the two triangles are similar. So once the two triangles have become similar, then their corresponding sides become proportional. Now let us come back to this diagram. Here we had seen that PF, the value is 6. So let us write here the value of PF is 6. And let us check the value of PD. Now here PD is the sum of PB, which is 6, plus BC, which is again 6. So 6 plus 6 is 12. Now the value of CD we do not know. So let us keep it as CD and write here 6 plus 6 is 12. So we have PD as 12 plus CD as we do not know the value of CD. Next, let us come to the small triangle. Here we have ME as 3 and here MD is nothing but the sum of MC plus CD. So ME, let us write it as 3 here and MD is going to be MC, which is 3 plus CD, which we do not know. So let me write here 3 plus CD. So let us try to find out the value of CD first. So we will take PD over MD first. So it is 12 plus CD. The corresponding sides are proportional over 3 plus CD. This will be equal to, from this triangle it is PF, which is 6 over, from this triangle it is going to be 3. These are the corresponding sides. Now let us just cross multiply, that is 3 multiplies with this and 6 multiplies with this. So 3 times 12 gives us 36 plus 3 times CD gives us 3 CD is equal to 6 times 3 gives us 18 plus 6 times CD gives us 6 CD. Now rearranging, let us take the like terms on one side, that is CD on one side and the numbers on the other side. So we take 6 CD minus 3 CD goes on the other side and it becomes minus. So minus 3 CD is equal to, so if CD is going on this side, let us take 18 on the side of the equal to sign. We get 36 minus 18. So here 6 minus 3 gives us 3 times CD is equal to 36 minus 18 gives us 18. And the value of CD is equal to 18 divided by 3, which is nothing but 6. So we got the value of CD as 6. Now once we have got this value, it becomes very easy to find out the value of ED. So for that we are going to make use of only this small triangle. So let us just write CD was 6. So here we get 6 plus 3, which is 9. So this is 9. And we clearly see that this is a right angle triangle and we have to find out the value of X, that is ED. Let me redraw it. So I have redrawn it over here. So we have EM with us, MD with us, we have to find out ED. And using the Pythagoras theorem, we can easily find out ED. Since this is 90 degree, the side opposite to it is always going to be the hypotenuse. And using the Pythagoras theorem, we know that the hypotenuse square is equal to sum of square of the other two sides. So here we have 3 square, that is EM square plus X square, which is ED square. So 9 square is 81 is equal to 3 square is 9 plus X square. Now taking 9 on the other side of equal to sign, we get X square is equal to 81 minus 9, which gives us X square is equal to 72. And sending the square on the other side, we get X is equal to square root of 72. And let us find out how much we get here. So square root of 72 gives us 6 root 2. So the value of the line segment ED is 6 root 2 units. So this is our value. So to solve this, we have made use of the concept of the similar triangles, and we also made use of the circle theorem, that is the radius tangent theorem. And using that theorem, we have proved that the two triangles are similar. And once we found out they are similar, we use the corresponding sides of the similar triangles are proportional concept. And then finally, we use the Pythagoras theorem to get the value of ED from the smaller triangle EMD. I hope you have understood all the steps and liked the video. If you know any other way of solving this example, do comment below. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.